All right. Hello, everyone. Welcome to the wasmCloud community meeting for Wednesday, August 16th. We've got a pretty packed and a little demo stacked community call today, so it should be a lot of fun. And I figure we might as well go ahead and get started. I'm giving the first demo, which is around the Wadham Actor Daemon Scaler. This is something that's like not officially released yet, but something that I'm kind of working on for an upcoming talk. So I'm really excited about it. And then after that, we'll come back and get a demo of event sourcing or the project concordance, code generation, and documentation enhancements preview. Also not out yet. And then we will also be able to talk about our roadmap, how it's coming, and a couple of issue milestones that may be worth keeping an eye on as we are running up to conferences and working on componentizing wasmCloud. So let me go ahead and change my share really quick. I think I'm just going to share my whole screen because I'll probably go back and forth between a couple of different things. Let me do this here. Go ahead and keep this there so I can look for any comments in the chat. Okay. So you may be wondering, what is the Wadham Actor Daemon Scaler? It's not Daemon, it's Demon, as Caroline informed me. Well, the Daemon Scaler came out of something that I've been wanting to do with Wadham ever since we first wrote the original spread scaler. And if you're unfamiliar with the way that Wadham manifests work in terms of deploying components across a wasmCloud lattice, effectively in the actual manifest for an application, you define the whole list of components that you want to be running in a lattice. And then you define a specific trait, and the one that we had support for previously and still will, but is called a spread scaler. With the spread scaler, this actually has support for defining a number of replicas. So you'll be able to do something like, say I want one copy of Echo running in the lattice, or I want 10 or 100 or whatever, whichever number you actually want. And then you can also define a certain number of spreads. And this is a relatively simple spread configuration. We can probably look up a more complex one. Here, let me zoom in just a little bit more because I know it always comes through a little different on stream. So here's an example of a more complex spread. So we're saying we want 5 replicas of the Echo Actor, and we want to spread it across hosts that have labels region for a test. So we had some fun with this: US Brooks East, US Taylor West, and then also running on the moon, of course. And then these also have an associated weight with them. Effectively, this lets you get really custom with defining your spread requirements across like a variety of different infrastructures. Now, what I have been working on, and I just added it, it's in a work in progress PR, so it's not out yet, is another type of scaler called the Daemon Scaler. And what the Daemon Scaler is for is just like a Kubernetes daemon set. It's effectively based on the spread that you define, going to spread in a component. Just for now, it's just actors, but it's going to spread this component across every matching host in a lattice. So this is the version of the manifest that I have deployed right now, or the one that I actually at least have put. And if we look at our one host here in the on the wasmCloud dashboard, it's effectively blank right now. I've just put this manifest Echo. And if I do wash app deploy Echo with this version, we'll see that Echo HTTP server, and then as soon as that's healthy, the link will come up, and now we can hit our Echo Actor. Now, what I really wanted to have is, depending on the application that you're writing, it could be really useful to be able to dynamically scale this application based on what infrastructure comes into the lattice. So if another host comes up with a matching set of labels, we may want to spin up an entirely duplicate copy of this application. Now for this demo, I'm just going to keep it to the actor because I don't know if you've worked with the HTTP server provider before, but that opens up a port. It's a whole thing. So, I'll always have to keep that kind of stuff in mind, but I'm going to scale this actor and basically say, hey, I want one copy of the Echo actor to run on every single host that has this label hostcore.os is Mac OS. So let me go ahead and update the version of the manifest. And then the type here, the trait for the daemon scaler, is actually exactly the same as the spread scaler. So it's effectively like a drop-in replacement. But now, instead of running one total copy on a host that's running on Mac, we're going to run one copy on every host that's running on Mac. So I can deploy this. Actually, I'll deploy the new manifest, which is Echo. And nothing is going to change right away. We only have one running host, but the daemon scaler is effectively doing its job, saying, hey, I'm going to run this actor on this host. However, this is a different thing. What we can actually do with wash is just like we've run this individual host here by running wash up. We can run another host, which will automatically connect into the same lattice and have the same system level labels. So I can run another wasmCloud host. And as soon as that connects, we'll see that another host has popped up and it's already running the Echo actor. It actually does it so quickly that I can't switch over to that tab. But if we look at the all host view, we can see that we have, I understand that this isn't the best visualization, but we can see that we have two running Echo actors. And then if I were to do this again, run another wasmCloud host, of course, this is going to have the Mac label. As soon as that starts up, Wadum is going to say, hey, that's a new host that has the label that I'm looking for, and then start up an Echo actor. So I'm really looking forward to coming up with a compelling demo for this. Like I said, I am working on this for a planned demo for the upcoming WasmCon conference. So this is going to be really fun to be able to say like, hey, every single host go start this application. But this is what the Wadum daemon scaler is. And if we take a look at the app status, we can see that it's ready. It's running all the things that we want it to. But if we were to shut down one of the hosts, for example, and we lose that Echo actor, it should still be, it's still ready. This is still an acceptable status for the daemon scaler because it is running an Echo actor on all the hosts that are running with that label. So yeah, this was a pretty exciting thing. I have to be honest, it wasn't all that complicated to actually implement this. You can go take a look at the code on your own if you want. I won't do a deep dive here just for time, but I think it only ended up being, I was able to reuse a lot of the same logic from the spread scaler, but like over half of the lines of code in that PR is just running, tests to make sure that it's working well. Let's see, I'm going to go ahead and stop sharing here just so that I can bring the focus on everybody again and see if there's any questions. That's the actor side of the daemon scaler. There's also going to be a provider side as well. It just works a little bit different. So it's going to be some more logic there. Jordan had a question. If you were to scale the HTTP server as well, how would you handle load balancing? I think that Kevin and Taylor are definitely getting at the point in the comments here. But around the HTTP server and scaling that, assuming it's not all on the same like local port, so you're running it on different machines and everything like that. Effectively, the HTTP servers will all spin up their own listener for that individual actor link, and it's not something that I think we're planning on. I don't think we're planning on doing something external to wasmCloud to actually load balance between those HTTP servers, kind of like if you have different machines in AWS or something like that. But I think we're definitely thinking about how that could be best done. I think ultimately that just comes up to, taking the endpoints that you're listening on and then using something at a higher level than wasmCloud, like in the infrastructure side, to load balance between those endpoints. Any other questions for the daemon scaler? Daemon scaler. Sweet. Well, oh, Liam.
Cilium meshing probes comment came in, or is that a whole separate discussion there?
Oh yeah, I think that's a separate thing. Tangent. Yeah, that's a good way to say it.
All right, thanks.
All right. Well, I look forward to showing off the daemon scale a little bit more. Plan to have a little bit more of a deploying a whole application demo. Perhaps I can show that next week or the week after, as long as it's not too much of a spoiler for the conference. All right. Well, then I think we can go ahead and move on to the next item in our list, which is let me trying to coordinate getting Kevin co-host so that I don't get yelled at in real time. It's going to be the concordance event sourcing code gen and documentation enhancements preview. So Kevin, go ahead and take it away.
All right, let's see if this works on the first try. Okay, so you should be looking at a Chrome window with some stuff from GitHub on it, right?
That's right.
Okay, cool. So for background, concordance is an event sourcing framework that's built on top of wasmCloud so that you build your event sourcing primitives as wasmCloud actors or WebAssembly components. And then concordance takes care of all of the hard work. And one of the samples that we've built is a simple bank account example that shows, just a basic aggregate and how to do, some really simple processing on it. And if we go through the code, you'll see there's a module called event sourcing that, and what we're looking at is before some of the enhancements. So I want to kind of compare and contrast between the old and the new, even though everything is sort of relatively new. In this version of the example, there's a build.rs file that automatically runs the Smithy code generator to build a bunch of stuff for event sourcing. And then there's an aggregate service that we implement for this bank account aggregate. And then there's a pile of boilerplate here where we basically just switch on the data on the type name of the various events. So if we want to handle a command, I forgot that thing clicks there. So when we handle a command, we go in and do a switch on the various commands and then run the right function. Same thing with applying an event is we apply the event and then we do a big switch on the event data type, and we manually invoke deserialize in order to run our own functions. So there's a couple of things that are not ideal about this. The first one is obviously that we don't have strongly typed handlers. So there's no, handle create account command. There's just handle command, and then we do a switch and a deserialize and all that stuff. So it's a lot of excess typing, and it makes most of our code, most of the useful information in our code appear below the fold. So that's no good. The other thing is visibility and discoverability. So if we've experienced this firsthand, where when you're building a bunch of event sourced components like aggregates and projectors, and which commands are handled by which aggregate and which events are handled by which other component, the only way to see that is to go into the code and look and hope that this information is accurate. And so that's no good either. So we've come up with what I think is sort of a better way to deal with it. And so the first thing I'm going to show is a better way to surface the event flow. So if you've used Concordance, within the last couple of weeks or so, then you may have noticed that there's an RDF turtle file that's used to define the event flow. And then, we generate some code from that, and we also generate some markdown documentation from that. But again, my tolerance for friction is pretty low. So even having to edit a turtle file, which is pretty straightforward, is not good enough. So what I wanted to be able to do is actually write documentation on my event model. So what I have here is an open source product called Event Catalog. Just making sure everybody can see this tab. I switched.
Yep, yeah, that looks good.
Okay, so I have an open source product called Event Catalog, and if you've used site generators like Hugo or Jekyll or Docusaurus or anything, this should look pretty familiar. And it's basically how it works. So, I've got these events for a sample application called Lunar Frontiers, where we have an event sourced lunar rover. And so let's see, I've got this rover initialized event. And so let me just walk through a couple of these things in here, because it's actually pretty impressive. And I'm not saying that because it's our project. The Event Catalog itself is a pretty cool product. So we've got the name of the event, a summary of the event. Then we actually have some, full markdown that we can use to document the event. This diagram is automatically generated. I did not draw this. This schema down here came from a JSON schema that I put in the appropriate directory. So this product is also automatically rendering the schema for this event. And so when I'm looking at this event, I can see that the rover aggregate produces this event, and the rover aggregate also consumes it for its own state, but there's also two other consumers. And so you're probably thinking, that's great, but how do you deal with, event versions? And, I'm glad you asked, Brooks. Thank you. So over here, you can see that we've got the latest version, and we also have this thing called v0.0.9. So if I click in on this, so now I'm looking at the old version of this event. I can see that I'm viewing an old version of the event. It gives me a big warning that I'm doing that. And you're probably thinking, it'd be great if I could do, I don't know, a diff between the old schema and the new schema so I could see what changed. And again, Brooks is coming up with really great questions here. If I do view changes on this, I actually get a diff of the schemas. So I can see exactly what was changed between 0.9 and the 1.0 version of this event. And this kind of visibility is something that is almost completely unheard of. You never see this when you're building event sourced applications. If you're using Kafka and you use Avro, and then you use a couple of other add-on products, and then a couple of plug-in code generators, you can maybe get close and do like Avro diffs or protobuf diffs, but even then, it's not nearly this cool. So if I go back to the event, it's a little slow because I'm running like the development version of the server, and this is designed to be statically generated. So I can run, npm build and then push it to Netlify, and now I have my site. So let's take a look at something that's a little bit more complicated. like the rover aggregate. Like I said, it's a little slow. So again, this diagram was automatically generated. I didn't do this. I supplied the metadata and it generated the diagram for me. So you can see I've got a command up here, and then some of these events. And that's great, but there's probably a better way to visualize my entire system as a whole. Again, thanks, Brooks. So if I click on all events and services, now I have a complete holistic view of my event sourced application, not just, what goes into one aggregate and what goes into another one. So I can zoom in and the what we usually refer to as ant lines, this animated marching stuff. This shows the event flow direction. So you can see that the rover aggregate is emitting all of these, and then you can see where they go. And I can move. Oh yeah, one of the other things I didn't mention, there's so much stuff on this that I wanted to demo that I'm forgetting all the cool stuff. In addition to these mermaid diagrams being automatically generated, they're interactive. So if I'm looking at initialize rover and I want to go to the aggregate, I can just click on the aggregate in the diagram and I'm good to go. So yeah, like I said, this is I had only heard of this briefly, and for whatever reason, I didn't go into too much detail. And then Bailey mentioned it the other day, and in super short work, I was able to put together an entire model for the lunar rover sample that we've got. And there's another cool feature on this. Again, I didn't generate these are generated by the app. So I have a 3D visualizer for my event flow. So now I can see that like the rover pilot process manager is like the linchpin of everything. It's receiving all these events, but you can also see kind of these little clusters where your building aggregate has the construction stuff, but it also feeds in here. And then you can also zoom out and find these islands of separate functionality. So you can tell that like this whole colony sub process that can probably have its own nice separate release cadence, because you can see the blast radiuses and everything else in here. You can organize things by domain. So I could do like, spaceships as a whole domain, and then put all the lunar stuff underneath it if I wanted to. So it's not, I don't have to have everything just top level. I can, while I'm looking at the event list, I can see the mermaid diagrams automatically just with this checkbox. So again, I think this makes an overwhelming difference in just the general visibility and awareness and maturity of an event source application. Like I can't imagine building one without using this system to document it. So one of the other things that I realized is I've got this documentation on this event source system. I know what the event flow is from the documentation. I know what the schema is from the documentation. So my next thought was, maybe I can actually reverse engineer code from the documentation. So again, I'm glad you asked that, Brooks, because I have that shown right here. Let's see, where is it? Yeah, here we go. Oh, that's the wrong one. Okay, so can everybody see Visual Studio Code right now?
Yep.
All right. So again, it's worth remembering just how high friction things were back in the old days. And by that, I mean 3 weeks ago. In the old way, you had to manually generate your event sourcing Smithy stuff and then build these giant switch statements. And you, within each piece of code, you didn't have any idea what the rest of that whole event flow looked like. There was no documentation. You couldn't drill down, couldn't figure out where anything was going. And so the code generation was, again, it wasn't good enough. So what we now have is this generate macro that should remind people of with bindgen. This path is the path to the documentation website for my event flows. So all of that documentation is now the source of truth. And as a writer, I can't tell you how happy it makes me that the docs are the source of truth. So here's, I point it to the website. I tell it that I want an aggregate and I want the rover version of that. It generated this trait, and now I have all of these strongly typed functions. So I've got handle initialize rover. I've got, so this handles an incoming command, and then I have the apply functions for applying the events to the aggregate state. And yeah, so the workflow now becomes, I model and brainstorm my event sourced flow. So I write down all my events, I write down all my commands, I build all my aggregates out, I see what that whole thing looks like visually, and I can actually see it in 3D. And then when I'm ready, I can just use this one macro in every WebAssembly module that is going to be bound to concordance, and that's all I need. So in old versions of this, there was a build.rs file. There were 4 different code generated .rs files. It was, it was better than nothing, but it was still pretty high friction. And now I think instead of high friction, we actually have an experience that makes it brain dead simple to set up stuff like this. So that's all I had for at least the planned demo. I can show what something specific if people want to take it, if you want me to dive deeper on it. Now, do people not care, or is this just stunned silence?
It's stunned silence, Kevin. I don't know what Brooks you were hearing questions from, but I'm glad that he had the good things, because I don't really, you didn't tell us what this demo was going to be, and I don't really know exactly what I expected. I kind of expected this, like this one, macro here.
Yeah, well, last week, this is what it was. Like, this was the extent of it last week, except instead of the path being a path to the event catalog website, it was a path to that hand-typed turtle RDF file where, I specify this event goes into this aggregate, this event goes into this aggregate, and so on. And that was tedious and boring. And I wanted something prettier. And a little bit of backstory is I tried using async API YAML files, which do plug into the event catalog website. And it's not nearly good enough. I ended up filing a couple of bugs against the async API plugin. But either way, so yeah, I'm super happy with being able to write my documentation first and then guarantee that my code is actually working against the latest version. And I mean, because I wrote this yesterday, so I don't support selecting it, but like I would imagine that if I want to, like it'll default to latest, but if I want to pick the versioned, a specific version of this entity, then I can do that. At least that's my ultimate plan. I'll save that for tomorrow.
Kevin, really what I wanted to say is that I can't wait to actually just look at this and run it on my own. Like I would love to start like from an idea to an event source application, like start with a template with this and then be able to go from there.
Yeah, that is the plan. I want to be able to spit out a new event catalog site, and then with like Hello World or something in it, and it would have a couple of like an aggregate couple of events and so on. So that brings me to another point, like this stuff here, this rover initialized, I'm currently hand coding this, like this data. But again, before I'm finished pulling the duct tape and bubble gum off of this, what are the things I should be able to do? Well, I can, because I've got it in another directory running, but is take the JSON schema that's sitting inside the event definition in the website and turn it into a Rust structure. And I verified that works. So it's just a matter of, stitching it together, probably with something other than duct tape.
Kevin, I'll ask one quick question, and then CJ had a few. Is this pushed up somewhere? Like, is this in a repo somewhere that people can take a look at, or is it still?
It's not. It's still highly volatile. Like, so just to give you an example, 2 days ago, the active PR for this was based on the Turtle RDF file. I got nerd sniped by Bailey, and now it's based on this website stuff and documentation first, and it's an infinitely better experience. So my plan is to just make it so that this stuff is usable by people other than me, and then I'll have that pushed up into a PR and then merged, and then we can just kind of iterate over it to smooth that out. Like you said, I want to be able to go through the process of creating the documentation site and then generating the code. And like, that's what I did with this Lunar Frontiers site. Like, in addition to coding all of the stuff that pulls from the site, I was able to actually write all of the content for that site in that short amount of time too. So it's all super easy.
So cool. Yeah, I can't wait to see it. Yeah, CJ, feel free to come on if you got mic access, but otherwise we'll get to your questions.
Yeah, I'm just wondering how the workflow looks like at the CLI build level, because I'm assuming that this generate macro actually generates the code that's below it. So once you put these in the file, are you going to have like a gen step, and then you go in and fill in those to-dos?
So what this stuff here isn't generated by the macro. Everything generated by the macro is currently invisible here. This macro generates the rover aggregate impl struct, and then it generates the trait. And then, to fill this out, I just stuck with the trait and then did, implement trait members. In terms of CI and CLI, thankfully, there's absolutely no CLI involved in this. Everything that you need is done by the macro. So the only real tricky part is in ensuring that your code has access to the event catalog markdown files when you build.
Cool. Okay. I just was making a dumb assumption then. That's nice and clean. Thanks.
Yeah. And yeah, I need to apologize for this red underline here. I have no idea why Visual Studio Code won't do this. This code does build. And like I can hover over this and it says I can't find the type, but yet there's the documentation for the type. So whatever, VS Code, thanks for nothing.
Yeah, I can confirm that Kevin has been doing the functional equivalent of screaming into the void in one of our like bad attitude channels about VS Code over the past few days.
Yep.
It might be worth it if one of us tries pulling it and seeing if it's not just you. You know what I mean? Like, what if it's an issue with some kind of macro definition in the REST analyzer, right? And we all get it.
I had that plan, and so I copied the code all over to another Unix box or another Linux box, and I opened it up. No underlines. It's just my machine. Thanks. Love it.
Okay.
But yeah, I figure sometime early next week, I'll be able to start pushing up bits and pieces of the stuff that I did here. So, you know, I cobbled all this together kind of quickly. It only currently supports generating aggregates this way, but like all the code for process managers and all the other components, it's all sitting there. I just haven't, you know, exercised it. So I'm sure there's bugs in there.
Nah, it compiled.
Yep, it compiled with red underlines. So
I don't see any questions on the live stream right now. But does anybody else have any other questions for Kevin here?
all right, cool. Yeah, like I said, I'll keep everybody posted. I'll probably end up doing a blog post and/or, you know, video walkthrough of this when it's in better shape, and I'll keep everybody posted during the weekly meetings.
Yeah, I'm speaking for everybody here, and tell me if you disagree, but I would love to have, whenever you've got progress on this, I would love to have a demo in the community call. This is just so cool, such a cool application of wasmCloud. It's awesome to look at. Alrighty, well, we are getting to our last agenda item today, and this is kind of a soft discussion time, but I really want to try and reserve time in the wasmCloud community call to go over our roadmap. This is really both a function of keeping everybody up to date and trying to keep me honest with the things that we are keeping on the roadmap. If you haven't seen this, this is in our documentation site now under this top level section for roadmap around what we're working on as developers and maintainers of wasmCloud for the, you know, essentially through the end of 2023. And our top level things we're really focusing on are leveraging WebAssembly interface types for all of our interfaces. It'll help us move to greater language support and, you know, continue to build on the WebAssembly language standard. We're going to be implementing and using wasmCloud instead of our wasmCloud interfaces that we've used up until now. We're really focused on backwards compatibility here as much as possible. There will likely be something that changes once you start to develop wasmCloud applications using components. But we're really focused, especially in this last effort around developing the wasmCloud runtime in Rust, on backwards compatibility with the way that you build applications with wasmCloud today. And there was a question in our community Slack. I don't know if it was last night or this morning, but I saw it this morning, and it was really around for developers or people who are looking at wasmCloud as a project, wanting to develop applications using wasmCloud and are seeing these, kind of major changes in the ecosystem. There was a desire to know which ones are really more of an effort on the maintainer side, like on the development of wasmCloud side, and then what is changing the experience for people who are developing apps with wasmCloud. And this is really important to know because for something like leveraging WIT for our interfaces, being able to use WIT for defining your own custom interfaces is much more desirable to picking it up now and defining an interface in Smithy, which will be, eventually deprecated with the move to components and WebAssembly interface types. So I really just want to be clear on some of the active milestones that we have. That if you look in the wasmCloud repository, we have two big milestones here. The first one is Witify, and this is all around using WIT for our interfaces, defining interfaces using WIT, and being able to use them for our code generation, like for providers. This is a really important one to watch if you're looking to develop applications for wasmCloud. If you're going to create your own custom interface for an application, there's certainly nothing stopping you from doing it in Smithy today. It's just a good thing to keep in mind. Yeah, thanks, Siri. It's just a good thing to keep in mind going forward that we're going to be using WIT for our interface types. And we would be really happy to work with you in the wasmCloud Slack if you wanted to get started today and then move to WIT. Us on the wasmCloud side, we have many contracts that are moving to WIT, so we're definitely going to be putting out a guide about, a migration guide from a Smithy to a WIT interface. The other larger milestone, which was updated 8 minutes ago, there are many things going in and out of this milestone all the time, is getting the Rust host up to feature parity with wasmCloud OTP. And this one is really something that we are focusing on the maintainer side, and is important to know, but not really something that should provide any hesitation for you building wasmCloud applications. Effectively, this effort is all around, taking the Rust host and having it be basically a drop-in replacement either on the Lattice or on the command line for the OTP host. And I just want to note that some of these issues in here aren't really ready for taking by somebody who's kind of new to the project. So like this one, for example, I just filed it yesterday because I thought I knew that it needed to happen, and I didn't add a description, and it actually is a duplicate, so we might be able to close that one. But anyways, I just wanted to be pretty clear about the efforts that we're putting in across the wasmCloud ecosystem. And if you're a developer developing applications for wasmCloud now, this first effort is one that's really important to keep in mind, that we're moving to WIT interfaces. This second one, which would be for net new applications that you're building with WebAssembly components, which we're super excited to add. We're going to be using standard interfaces instead of the ones that we've been using for the last couple of years. This is going to be a really awesome way to build WASM applications in general, but for you to be able to bring that to wasmCloud without using a proprietary interface. And so these milestones should be really great for if you just wanted to keep an eye on how we're doing on these and see how they're progressing. These are going to be changing rapidly, but that is essentially where we're at. I also wanted to just do one more call out that there is the last PR for validating manifests is going to be merged into WADM just a little bit after we stop this call. And then solving one of these final bugs, WADM will be ready for a release candidate. So 0.5 RC1 should be going out pretty soon as well, which will include some of the things that we've been demoing, like manifest upgrades, manifest status, and things like that. So WADM is making very healthy movement and should have some pretty exciting updates. As soon as 0.5 is released fully, we'll get that into Wash, and then you all will be able to play with that officially in the next version of Wash. So looking at the development roadmap, that's effectively where we're at. I don't think there's any more information from the official quote unquote roadmap that you could then that would give more information that kind of what I just kind of spieled about, but it's all looking really good, and I'm pretty excited about it. Does anybody have any questions on, the roadmap, kind of ongoing efforts that we're taking on in the wasmCloud ecosystem? Sweet. Then I think we can probably leave the roadmap discussion there. I'm gonna try to continue to update people as we in each community call about how we're moving on those milestones. And I'll see about opening up a milestone for the wasmCloud effort. I know that there's already been a good amount of movement there. Like we do already support some of the interfaces in the wasmCloud host. So I want to accurately capture where we are with that. And really, it's really exciting looking forward as we start to build applications with components. So I can't wait to have you all try some of that and get some demos in here of building WebAssembly component apps with wasmCloud. All right. Bailey just sent me like 45 links here in the Zoom chat, which I did open. The last little section in our community call agenda is just to always remind me that I need to talk about the WasmCon, which is coming up here in just a couple of weeks, actually, in September 6th and 7th in Bellevue, Washington. A lot of people on the wasmCloud maintainer side will be here, will be there, which is really exciting. Bailey, did you want to say a little more? I'm happy to spiel about it, but
yeah, I figured I'd give a shout out to some of our talks too, specifically. We've got a lot. So Brooks will be, wow, you have that many too? Dang, you got a lot of work to do. Yeah, so we've got just those. I'm also giving a keynote. Liam's giving a keynote in addition to those other 3 talks. And we're running a workshop for Cosmonic, which will obviously be showing off a lot of the power of wasmCloud.
And Bailey is moderating at least one talk, possibly 2.
Oh, that's right. I am moderating the host panel. So we're going to have folks from Mozilla and Google and the WebAssembly chair to talk about how the WebAssembly standards and implementation for browsers impacts really a lot of the roadmap and impact in the ecosystem. So I think that'll be a really fun discussion.
And then I know that we also, not too shortly after, but coming up at the end of the year is going to be Cloud Native Wasm Day, which is kind of a regular staple now at KubeCon, so the co-located events. But Cloud Native Wasm Day is going to be pretty sweet. I don't think that the CFP is closed, but the schedule is not out yet, as far as I know. So that'll be coming soon. We'll certainly update you all if we can get some exciting talks in there. That'll be fun. Let's see, is there anything else in the conference world coming up, Bailey or Liam, that I'm missing? I know that this stuff.
Did you mention componentize the world? We'll have remote capability there. So you can join in and start learning how to use some of these tooling. It's going to be focused on the Bytecode Alliance side of this. So a lot of the Bytecode Alliance projects are sort of upstream to wasmCloud. We rely on them, and including WasmTime, which is our runtime. There's also projects called Wasm Tools and WIT BindGen, and you can use those to basically componentize dependencies throughout the entire WebAssembly ecosystem, so that onboarding to WebAssembly is going to be that much easier. So the goal of this is to basically effectively bootstrap a component native ecosystem.
So Bailey, as soon as you said that, the wheels started turning in my head. So like the goal of this, or if I could come into this like a componentize the world hackathon, like I could find a library that's like only written in Rust that I'm super passionate about, and I could turn that into a WASM component. And then like you from a not rusty language could be like, I'm going to use that library from only Rust, but from any language. Is that the?
Exactly. Yeah. Just like,
cool.
Hopefully everybody gets that mind-blown experience of, wow, okay, I get it now. This is why we build WebAssembly components. We can now use a language written in any other language, and now that's just another tool in my toolbox. I also think it's funny because you had mentioned a Rust project called Names earlier this morning, and I have an Excel or a Google sheet that's got a bunch of the projects that I've gone out in the Rust space that a lot of people rely on, and that's one of them. That is in my, hey, you want to get started, and what's super easy, like really shouldn't be too tricky to convert to WebAssembly. Names is one of them, right? Because it's moving strings in and out, and doesn't really rely on too many other hardware kind of features. Those are going to be a little bit harder, but yeah. So I've got a list where it breaks it down from easy, medium to hard.
That's super cool. I know that this would have come in handy like so much. Jordan, what was it, like maybe a year ago when TinyGo didn't have like the JSON packing that Rust did, and you wrote an example in wasmCloud that did an actor to actor call, like a TinyGo app actor called a Rust actor to serialize it and then bring it back. That was it, right?
Yeah, good days. Good days.
Well, can TinyGo do that now? We
Yes, they did fix that.
Okay. Yeah. No, it's such a big props to the people in the TinyGo development community. They're always doing awesome stuff, bringing things in from the Go standard library. Yeah, cool. I'm pretty excited for that. Bringing in some crates. At risk of putting you really on the spot, Bailey, how is the componentize JS effort coming along around componentizing a JavaScript component? Because I know there's like approximately 500 billion JavaScript libraries out there.
Oh, it's solid. It's quickly becoming one of the best supported with bindgen targets. And so that project is called JCO, JavaScript Component Tooling, and then a sublibrary of that is componentize JS. So that's the piece that actually, takes that JavaScript code and turns it into a component. But JCO also includes a ton of other different kinds of tooling that makes it easy to take your code and run it in a browser or run it server side. Obviously in a browser, you don't have the component models supported yet. wasmTime is the first runtime to add that support. And so he's got basically a suite of tooling that helps you polyfill that in environments that don't yet have the support. And that technique can actually be applied to anybody trying to run in a runtime that doesn't yet have component model support. And so, yeah, I've built a few things with JCO. It does tend to be like, a few days behind when we roll out new stuff, but I'm expecting us to hit a level of stability within the Bytecode Alliance tooling soon, so that there's, the lag you don't really quite notice because we're not changing syntax every other day. So we're very close.
That's so cool. Yeah.
Actually, I had Guy on the Bytecode Alliance community stream 2 weeks ago, and he showed off another project that he works on. Guy Bedford, he works at Fastly. He is the main engineer behind JCO and componentize JS. And he also built a tool called wasmVirt. And I like to hype that one as well, because that's something that's going to be a really great pair that I think we'll bring into the wasmCloud ecosystem for virtualizing things like the file system and other things that WASI enables, but being able to basically do that without having to actually provide a file system, provide something that's a virtualized file system.
Bailey, we had a question on YouTube, which if I understand it right, they're asking, well, I wanted to see if you would consider opening up that, spreadsheet basically that you have in, it doesn't have to be now or in its current form, but basically turning that into a public thing, just your notes around what makes it easy to turn it into a component versus hard, and then really good candidates for components. That would be a really great thing to have kind of as a reference, especially for the Bacon hackathon.
Yeah, totally. I just started on it, if we're being honest, but I went to crates.io and did a search for most popular downloads, and then I quickly realized there were several that don't make sense to be a component, and that would be like Rust macros. Another example would be things that require a lot of FFI kind of work already built in. There's a lot of like FFI style binding stuff, glue. So generally speaking, I guess if it's language goo, not that one. But I think my goal was to try to get one good library example of each sort of utility that people are interested in. And then I've got separate sheets for JavaScript and Go. I would like to add more as we have more languages, but time is short, and we've got 3 weeks. But yeah, I encourage anybody if they have a good feel for it to drop something in here. The things that move from medium to hard are ones that are going to require a lot of the new WASI APIs to make it work. So that takes a level of knowledge of the ecosystem that a lot of folks don't have yet. The things that make it medium, generally, I was thinking things along like many lines of code, in looking at what dependencies it depends on. So if it has a lot of dependencies, it usually means you got to convert those to upstream dependencies. That's kind of that's the sliding scale. I'm hoping to find more easy ones than not, right? of having those enumerated so that anybody can come in and try something and get something contributed back out to the community. Like the goal is for other people to be able to create basically GitHub PRs in I don't know how to say his name, Fincol, Fincol/names. That would be great.
Yeah, I can. Oh, and I know we're at time, but I'll say my one more comment and then wrap up, I guess, because this is too cool. I'm looking forward to the what's the right way to say this? The flood of PRs into libraries. It's like, hey, you just swapped out this one thing, it'd be compatible with a WASM component, and here's the PR to do it. That's gonna go harass all the library maintainers. All the fun stuff. But yeah, Bailey, if you want to do that one little shout out before we head out. But this is a really awesome call.
I feel like there's so much happening right now in the space. So there's a special interest group within the Bytecode Alliance that's around guest languages. And so guest is like that thing that you compile to WebAssembly, right? That's the guest side. And the host side is your WebAssembly runtime. And so this is focused on getting upstream languages to have WebAssembly component support. And with Go, 122, I believe, now has WASI Preview 1 support for command modules, and now actively working on being able to support Reactor style. We're very close to that also fitting really well with all the things that we wanted to have. But there are several different patterns that can broadly be applied to just about everybody. What bindgen generations like for Zig and Rust and C++, like a lot of that works across them. But there are a lot of other patterns that work really well for languages like Python and JavaScript, where they need to bring in basically the interpreter or compile in the interpreter. So there's a lot of techniques there to make that performant and not take up a lot of memory. And then now there's one for Go. So there's basically a Go working group within that special interest group that's just focused on trying to make something feel Go native and not feel like you just slapped a bunch of CFFI gook on a project. So that's happening right now. And if you're interested in getting Go working, I'm looking at Jordan. Please do join and give them good feedback. And Jordan's parser's been getting a lot of shout out in that space too, because they want to be able to contribute too, and not everybody wants to code in Rust.
All right, everyone. I'm gonna close this one down before Jordan comes in and talks about not wanting to code in Rust. Sorry, Jordan, for giving you a hard time. Thanks everybody for coming to this week's community call. Awesome demos, awesome progress in the WebAssembly space. It's really just seems to get these calls get more and more exciting as the year goes on. So thanks all. We're gonna go ahead and stop it now, and